Okay, welcome to chapter 4 of our little tutorial playthrough. This time I actually have some kind of game plan. Let's see what that is. First thing I want to do, I want to move the arc furnace, and I will show you why. It's going to be quite cool, I think. It's something I've never done this way. Then I will have to smelt some alloys. You know, we have to consider the pressure and temperature and the mixture, but that's easy. The alloys will be used to build some stuff that we haven't seen yet. And for example, the IC10 and the housing, because we are going to do a little bit of assembler programming this time. It's going to be rather easy. I mean, you will actually see how uncomplicated it is, apart from a few details. And I intend to upgrade our manufactories using the alloys, and then I'll try to put up a deep miner and a centrifuge, and of course a recycler too, because the three are kind of a package deal. And we're going to do some mining with a pneumatic mining drill. At least that's the plan. Now let's see what actually happens instead. I went out mining, so we have some more resources, and ordered things a bit better here. And during this time, our potatoes actually completed their growth cycle. And like I said last time, at the very end of the growth cycle, plant will just keep standing like this and will keep breathing for me, will keep creating oxygen from CO2. Actually, good thing that I'm thinking of this. If there are many plants, then they will easily breathe up all the CO2, and then they will die, so that has to be considered. One way to remedy this is to just open your own waste canister in this room every time, because there's obviously a lot of CO2 in there. Okay, we have seeds. That is the last step of the growth cycle. If I click here, I hold them in my hand. And then I can click again, and that will give me potatoes. Yeah, we just have our first potatoes. Okay. Now the question, will I replant a potato and a seed? Will I keep the seed here in my chest where I had 3 but now have 2, so I replenish to the original scale so that basically nothing has been used? Those kinds of decisions have to be made, but I will just bluntly plant this. We'll also plant the potato itself, and one I will keep because now the agenda changes. That was not planned. I will put up a table and the microwave so we can get some tasty potatoes. There's no space here. Kind of a problem. Well, let's push them aside then. They can grow in a corner. Tables. The tables come in various flavors because they are once again a kit. But most of these or all of these are powered. No, some are not powered. These are more decorative. And they're more decorative items. There's, for example, chair and some planter, stuff like that. But let's put up a table, something that fits the style of what we already have, something solid. Where do I put this? Let's put it here. And give it some wiring.
Power low.
Microwave, where did I toss you? So, I can place it here with Q, which is a bit daring, or with T, that is less daring, because then I can actually point and then click again. Now I need the wrench. Okay. Now it's attached and wired up to the table. So if I power this, this can also turn on. It's flashing an error because the microwave wants something inside of it. So let's put the potato in. Only one potato, Vasily. Yummy, yummy. I think that if a potato has decayed somewhat, it can actually be... Oh. It can actually be put in there and turned into a baked potato, and then the decay cycle will start anew. I'm not sure if that's the case. If so, I hope they do something about that, because that's cheating, isn't it? Now I have this potato and it will slowly decay. I mean slowly, it will take a while. I think what it's saying here will decay in 7 hours is indeed referring to real world hours, so that's quite a while. But we can extend that time a lot by having a fridge. Where would I put a fridge in here? Can I actually build one? Fridge. Press F1 for Stationpedia. And here we have the small fridge, the large fridge, and the kits. That's always in there, you know. The kit is the thing that I need to build the fridge, and the fridge itself is the device that is then described with all its properties. I have never built a small fridge because I heard that they're kind of superfluous, because the large fridges are much better, and they are not so much more expensive. What do they actually need? So here you see the details, and if I scroll down I see the kit that leads to the fridge, and then I can see what's required to make that kit. Iron, gold, copper, steel. That's reasonable. What do I need? Electronics printer. Let's make one. Let's not let that potato go to waste. Iron and gold. And copper. Okay. Where will I put this thing? Remember to click here to make sure that the device will not produce anything further after the current process is finished. Oh yeah, schon already done. That's our fridge kit. There is only one item in the kit. Mouse wheel doesn't help us there. Where do I put the fridge? Yeah, it's getting kind of cramped in here. Obviously a base extension would be nice, but I'm trying to get around that because I want to get things done instead. The power is on the back side. You can see here on the right side of the build goes very slightly that there's a switch. That is the front side then. If I put it here, I cannot wire it. So, I mean that's awkward, isn't it? But let's do it anyway. Power. That thing will of course require electricity the whole time, so we should also think about putting up a solar panel or two. And all of that is us using resources, and the first step that I had planned for this video was to solve the resource problem a bit, because I mean I mined some resources, but they need to be smelted. Ah, sound of freshness. Currently we have 7 hours left. And now it's 2 days. That's worth it. Since we're playing on easy difficulty, we don't need so much food, so this box of potatoes would even last us on the hard difficulty. But the game will probably be changed later, not just regarding amount of nutrition, but primarily that you would also have to eat other things, else your body might suffer. Or that eating other things might make you more effective. I mean, it's thinkable that possibly the amount of food and water that you have to drink all the time might change if you change things up, so maybe your body can like store more of that stuff within it. That's a suggestion I recently saw on Discord, where the core crowd hangs out with the developers actually. And that's a good idea, actually. Yeah. So... turn this off, because that too uses electricity. Potatoes, fridge, the arc furnace. because I want to build a chute system. What are chutes? Well, they are like, what's the term? What are these belts? Belts? Transportation belts? Yeah, I actually don't... You know what Mr. Ford came up with. There are basic chutes and there are powered chutes. The basic ones, of course, need less resources. Do I have some iron that I can toss in there? Yep. And let's see if I can actually toss it in there. Haha! Okay, more of this. But where would I put the arc furnace? Up here would work, I think. There's also electricity. So yeah, that completely makes sense. How many do I need? One for the inlet, one for the outlet. No, I don't need an inlet. I don't know, let's see. By the way, something I noticed. Since we have installed and assigned, primarily assigned, the light here, it will turn on before the airlock does anything. So this light, as nice as it may be, actually makes the whole airlock cycle slower. So you might want to consider that. Let's remove this. If I point any tool at a thing, it will tell me what I can do with any other tool, with the respective other tools. This game has some cheating possibilities, which you should, if possible, not use. For example, if the furnace is about to explode and you can't relieve the pressure in time, or you don't have piping to do that, I think you can just unbuild it down to its last stage and then remove it, and then the pressure will be gone instead of being unleashed in the world. But I'm sure the developers want to do something about that. For example, the air scrubber has the same kind of feature. You can use the screwdriver, no, the power drill to unbuild it, I think, and then all that poison that's currently inside will just be gone. What should happen instead, of course, is that it's unleashed in the atmosphere. Or can it not be? I remember that this canister, if I hold my drill against it, it will say you cannot unbuild this now because it's still full. Maybe they implemented that already for this thing too. Okay, the arc furnace up here. No! Oh my god, it's on the inside. Me and my choices. No more cables. Okay, whenever you do such a thing here, you have to weigh the implications. This was of course reasonable, but in some situations you might not want to cut a cable to your system. Okay, now it's powered, now it will constantly consume electricity. Not the best plan maybe, but... Do I have the resources to put up another solar panel right now? Yes, but I should structure this more. I've come to add chapters to the YouTube videos, so it makes sense to separate topics a bit more. Okay, this is once again a kit. We have the straight chute, which is just a, you know, a box like that, goes in here, comes out the other side, but I cannot use it like this. This is just the middle piece of the entire construction. And similar to that is the window chute, which is placed in the window. That's why it's called the window chute. And yeah, it's the same as the other chute I just showed you. But you can see what's inside. That's sometimes quite desired. But you have to consider, you can actually put ices in these systems, in these chute systems, but if there's even one window chute in there, the ices will start to melt. So yeah, don't. I mean, depending on what you're doing. Also, the window chute takes 2. See, 6, 4, 6. Then we have the corner piece. Once again, the auto rotate key is your friend. Then we have already had the straight one. The junction, obviously, you can come from 2 sides and then it will join into one. The opposite of that is the overflow chute. Was it the flip-flop splitter? Honestly, I have never used that, and maybe that's a shortcoming now when I'm trying to explain that. I always used the overflow chute, which goes straight unless it can't, and then it goes to the side. And with the chute inlet, if I place that here, then I can toss something inside of it. That will actually be used in our system here. What else do we have? Window junction, flip-flop splitter, valve. The valve is something with a lever that is turned off by default, and I can turn it on, it will stay on, and then it will let stuff through. Quite relevant sometimes, yep. Inlet, outlet, straight, corner, window. I think that's it. Okay, I think this thing is already connectable. I don't need an outlet here that connects to this inlet or something. Question is, can I place the chute here vertically despite the cable? The answer is nope. So that was not the best plan. Oh, that should work. Yeah, let's do that then. Corner. Straight. And down here I put an inlet, and then I can throw stuff into the arc furnace and it will furnace that. And when it's done, yeah, guess what? A corner piece. And can I place the outlet actually directly here? That would be cool. No, I can't, because the outlet, for some stupid reason, is only available as a corner piece. Outlet. Here, look at the outlet. That's the arrow shows where the stuff is moving, and now on the left side of the screen you can see where it will be thrown out, and it feels wrong to throw that out within the ceiling. So let's not cheese that. Instead, use a straight one. Actually, I wonder, do I need the outlet at all? Shouldn't it come out just like this? I wouldn't consider that cheesing. Let's try it. Maybe we're done already. I mean, the light is cool, but I think I will unassign it. Saves us some time. Where's my disc? My disc is now on me, in my very personal uniform. By the way, you can actually print other uniforms, and there is a DLC available where you can print country uniforms for all kinds of countries. Germany, United Kingdom, Ukraine, Russia, United States, all of them. So, active vent. You can see here active vent. That is probably the active vent over there, back there, where we have our cooling system. It's actually something I ran into when I came back from mining. I was looking at the plants and it was saying growing poorly towards fruiting. And the reason was that it was too hot, and it took me a while to figure that very obvious reason out. Why did it take me a while? Because usually my bases are automated and take care of temperature themselves, so that wasn't the first thing for me to think of. So I see everything on the current cable network listed here, even the water bottle filler. So we have the light, let's unassign it, and oh nope, that was yesteryear. Turn it off. Let's test the chute thing. That's the outlet, that's the inlet, and here's my... No, let's do something simple. Only one. And... Oh, I didn't place the inlet yet. Okay. And I produced 1 too few, because the inlet, like the window chute, takes 2. And you're gathering already that these are airtight, so this means you can put up an inlet up here, an outlet down there. Between them you always need a normal one or a windowed one. So I can toss stuff through here and it will come out the other side, and vice versa. That's quite convenient, especially when you're working together with other people on a server. Or in a shared game. You don't actually need a server. Inlet. The multiplayer capabilities of this game are really great. Completely easy, implemented in multiple ways. And they even made sure that if even if Rocketworks would eventually go bankrupt, oh goddammit, I said eventually like an idiot. If Rocketworks would go bankrupt, then the game will survive and the multiplayer too will survive. Okay, let's throw that in. Does it come out? I get the feeling we actually need the outlet. Alright then. Should I point it to the left? I'm curious what happens. Let's do that. I'm blowing up my furnace so that you don't have to. Chute outlet. There's something wrong here. Shouldn't it have completed the smelt already? Did it turn off again? Damn, something's fishy. Step 1. Take a look at the arc furnace itself. Oh, damn. I forgot something. It will not turn on automatically. You have to push the damn button. Now it fell down, so it doesn't hurt that it is pointing in that direction. Okay, but there's a solution for this. There's always a solution. Only it's a solution that we can't yet implement. Window, junction, straight. Come on. Yeah. And that solution is to tell this thing to turn on with logic. There's a logic connector somewhere. It's probably within here, so I have to move these. Let's do that right away, so we don't have that hassle later. So I'm hoping that there's no hassle later, which the German word for is hoffen, so I am Hasselhoff. Yeah. Come on, let me in. But it's a bit faster now. Wrong side. Oh yeah, and the advanced-ish things here, they have to be undrilled instead. There. Connection, data connection. That's what we will use, and we will use some logic chip to tell it, turn on, dude. Turn on and turn on again, and then you turn on again. I have never done that, by the way. I'm not sure if this will work. I might have to look this up online, but usually the solution is pretty much straightforward. So, shoot again, because you need one more now. Yeah, now our smelting has actually become more complicated than before. That gives us a good reason to try to solve this, which we will at some point. in the future. Junction. Outlet. It is green, aka that's not correct. Let's press the auto rotate key while pointing at the surface of where it's supposed to come from. Yeah. Okay, let's check the agenda. I think alloys is the next thing. Yeah, we need those. And since automation is quite high on the agenda now, let's see what we need. That would obviously be the electronics printer. What we need for the kind of programming that we want to do. Now, let me first show you some of the logic chips, which I don't want to build now, but, you know. Kit logic processor. Okay, so we can produce an IC10 that is currently not listed here. That is a chip where you can actually have 128 lines of assembler code, and we will need a few of those. I hope they will expand this because that is really too little. Double that amount would be fine, I think, but that should be the minimum. And assembler, that sounds super hard, right? But it's not really, because ultimately you're just telling the computer, this is the thing that I want to refer to. Now give me of that thing this and this parameter. For example, give me of the gas sensor the current temperature. Then you say, now that I have this value, add to that, subtract from that value 273.15, which is what 0 degrees Celsius is compared to Kelvin, because you get your readings in Kelvin. So that sounds complicated, but this complication was not related to the programming at all. So give me of that thing the temperature, adjust it to Celsius. I mean, I can just, of course, keep it Kelvin, but I'm just more, you know, it feels better for me. And then we can say, if this is greater than 23, turn on the active vent. If this is less than 23, turn it off. And then we say jump back to start. That's basically it. And then there are some details like the yield command for better execution flow and stuff. But those are all details. What I just described is ultimately what happens, and how you tell that the computer, that's then the complicated part. The IC10 needs to be put down on an IC housing. Yeah, and you can actually write values to the IC housing. So if you're standing in the room and point your mouse, the crosshair at the IC housing, you can see the value. For example, if I read the temperature, then I can just write it to the housing and then can point my mouse and I will see the value. Or for example, the battery level in our station. Now, there are also logic circuits, but I never really bothered with them. I tried them once and used them, and that worked well, yes, but I needed a chip for this, a chip for that, then a memory chip to compare a value to, and stuff like that. And that was just too tedious, and actually I have been a professional programmer for decades, so of course the IC10 came more naturally to me, and I will try to show you how easy that actually is. So those are the logic chips, but maybe I explain a few things about the logic chips now. This will all be theory because I don't intend to to print them now. We have the kit logic memory. That is just a chip on which you can store a value. For example, one chip could read a gas temperature from somewhere, and then you could write it in the same breath, I think, to this chip, and then another chip could compare something to this value. Then there is logic I/O, logic processor. I'm actually not sure. Let's look at the Stationpedia instead and do it while paused. You can also do this from here. God damn it. Why isn't this working? Okay, you have the kit logic processor, which gives us, for example, the logic math unit, which has features like add and subtract and multiply. You can see here, I hope you can see that if you're watching this in 4K, little screws that you can adjust with your screwdriver, so you can't change them accidentally. and they will define from what unit to read to what unit to write, and in this case then which math function to apply. I think that's kind of how it works. The logic select can be used to, you can have like multiple inputs, but you can choose which one you will use based upon another input, and then you can output. Then this screw will basically just be the connector to the next chip, and the next chip will then read the device on this side, whichever device was selected by this, as if the device was connected directly. I think that's the way it works. Math unary, actually don't know right now. Oh, here we go. You can see what it does. You can, for example, turn a negative value positive, or can invert logic. The logic values are 0 or 1. Okay, I'm going too much into detail here. Logic gate, what does it do? Logic gate, of course, is AND, OR and such. Most primary operation. Greater than, less than, equal and stuff. Minimum, maximum, what does that do? Huh. I didn't prepare to tell you about this stuff. I prefer the IC10 because, you know, when you program, then you can just write down what the computer is supposed to do, and it will do that, and you can move on with your life. You have to learn a little bit more for that, but that's the convenient way to go instead of wiring up all these logic chips. The logic chips are for beginners, but I actually think that programming is easier. So, where do we go? Let's produce an IC10. And then we will see it requires solder, that is, it requires lead and iron, and electrum and gold. Gold requires gold. I think we have that. Yep. And we will need electrum. That's a 1-to-1 mix of silver and gold. I actually realized on my mining excursions I failed to find some silver. And we need solder. We can make that. Okay, I will now pause the video to get some silver. Yeah, this is me getting some silver. Why am I not doing this off camera, like I said? Because hilarious. Dude, I hate this fucking mining drill. It's too slow. Let's see what this takes. What do I need here? Copper, steel, we need solder for that. Should I just make some solder right now in the pneumatic mining drill? Let's actually do that. Change of plans, mining drill first. So, let's look up in the Stationpedia what solder requires. This is the ingot solder, and we can see here it can be done with a simple furnace. Actually, it's here, simple furnace. Actually, the actual simple furnace is the advanced furnace, because the advanced furnace has two pumps. You can just pump in some fuel, and you can just pump out some of the pressure within just by turning a wheel. And that makes it really easy to adjust your temperature and pressure. That's the simple furnace here. I think the chute inlet that it has, just like the normal furnace, can also just be used to toss ices indirectly. Meaning, if you would have that thing now, we would actually have an easier time. But guess what? The advanced furnace in turn requires electronics printer tier 2, for which we don't yet have the resources. So yeah, stuck, catch 22. Solder requires a temperature that is rather low. Everybody who has ever made solder in this game will remember, oh, the temperature is so very low. Yep, and to get down to the temperature will then be the trick. and a pressure of 1 megapascals or more. These numbers might still be kind of, oh, that's a number on screen, the number. But you know, you can actually get some kind of feeling for this space. It's, I mean, you would learn engineering here. These are real numbers. I don't know if solder is actually made like that. That's not the point. The point is these numbers mean something, and the meaning of these numbers will be learned by you. And next time you read those numbers, the fact that they have meaning will make it easy for you to remember them. So, let's get the ingredients. I already have this. I don't have... Oh god, do I not have any oxide? Or do I? Do I have oxide somewhere? Where would I have that? What happened? Where's the oxide? I had so much oxide. Oh, the jetpack, by the way, it has a mode that you can switch. I don't know what the default key is, just like I changed J to Shift. I'm using Shift to turn off and on my jetpack. I also changed that mode toggle switch. It is the tab key for me. Now I have my levitation locked in place. That's the default mode. Now I turn that off. And it's as if I'm walking around normally, except the jetpack is still on. It only pushes when I move around. I need some oxide. There's some oxide. Mining drill, thank you very much. Okay, like I said in another video, you have the possibility to create a better jetpack, and that jetpack, when you turn up the thrust, will really throw you around the world at ultra speed. I mean, at least vertically. Horizontally not so much, but still, it's much faster than this one. But we can't build that yet, because it's really advanced alloy stuff. The furnace that we have already allows us to make the alloys that we need for the things we want to do now. But I think the hard suit jetpack requires advanced alloys, which can only be created with the advanced furnace. Once again, the inventory is full. You might have noticed that some things that you mine will give you very little per mined ore, and some other things give you a lot, and that's indeed so. But that is dependent on world definition, depending on which world you play on. And you can actually customize that using mods, using modding. There are various levels of modding, and like I said, there is, for example, a level where you just put some XML file. What is an XML file? An XML file is just a normal text file, except it has a very specific structure within it. And you don't have to write those from scratch. You can just use an existing copy, change the values that you want. For example, if I use a difficulty mod, then I change the amount of food and water consumption from like 1.6 to 0.7. And then I plop it in the right place, and then it's available for me in the game. It's really uncomplicated. I mean, it's like the programming with MIPS and IC10. There's a little hurdle at the beginning, but later it's like totally easy. So I want to make some solder. I put these up again for that purpose, to store some stuff. One thing led to another, huh? You see that we have inconveniences. We don't have enough space. Things are disorderly. We have to do things by hand. So that is your will being triggered. And so it builds to a point when you then choose to do something about it. And in this game you can do something about it basically all the time. So there's an endless ocean of things that you can do and actually want to do. You just have to try to find out what the immediate thing is that you want to do most. Then you do that and the rest will emerge. I mean, I would like to build rockets at some point, but if I now focus on rocket building, I will only see all the obstacles in the way, instead of enjoying that thing that I'm doing right now and saying, hey, I can smell some lead, some solder. I could put the iron and lead in right now, but this would the furnace is not yet fired up, so the chute wouldn't open. So I would have to click 50 times for an ignition that will draw in one of the respective things here. I have to see to that this thing runs first. Do we still have some pressure in there? Yep, 2 megapascals actually. That's very good for our purposes, because we need 1 megapascal of pressure for what you want to do. So it's good that it didn't completely bend the furnace. So now once again the trick with the full hands. Or can I do this? Is it cold enough? Can I split without risk? Yep, apparently. You need 2 volatiles and 1 oxide for a proper fuel mix, but I do not want to aim for a proper fuel mix. I want to aim for a very low, but hotter than current, temperature. And maybe that is already enough to achieve that. So fuck the proper fuel mix, I just want the temperature. Oh, look at that. The correct choice was made. So toss in 50 iron, or whatever amount you want, and then toss in the same amount of lead. It's done. And toss in the lead. All these ores, if I mine them by hand, have their own gases. I showed that in a previous video. You can look it up in the Stationpedia, F1. And those gases will be unleashed, of course, when that stuff gets tossed in there and melts. That's what can, for example, build up the pressure. You can see here is higher now. We have a temperature of a nice temperature, and we can see the lamp is green. I think the advanced furnace actually doesn't have that feature that the lamp goes green if the mixture is correct. I'm not sure, but this one does. So here we go. Solder. Haha, now that was easy. Try to do that on Vulcan, where the temperature ranges from 120 degrees Celsius during the night to about 600 during the day, and your furnace is obviously outside because you cannot afford having even more heat generation indoors. We need this in tool manufacturing. So that thing will be always hot, probably hotter than your than solder needs. So yeah, tricky. Vulcan is an engineering dream anyway. All the things that you have to do to get by is awesome. So, drill. Here we have the pneumatic mining drill. What does it? Need copper, steel, and solder. Copper. And he makes the pass and... yeah. Copper. Steel. Steel. I think we have enough steel for now, but where is it? Here. Haha. Oh, yeah, more copper, please. Yeah, these things are coming down from the ceiling are obviously a bit sucky. We could, for example, expand our... Actually, I could probably build that in a way that it points down from above there. Maybe I just built that stupidly. And here, when I want to go out, because of my little stair-step effect here, I'm always hitting my head here. Not good, very cramped. Maybe we will get to that eventually, but let's stick with the tutorial-ish stuff so that you can learn something. Pneumatic mining drill. It will take some air pressure, gas pressure of whatever kind, so I need gas. Now actually the moon is a sucky place. Because on Mars and many other worlds that you can play on, you have some kind of gas, some kind of atmosphere to draw on, but here you have nothing. You have to obtain the entire atmosphere yourself all the time. I mean, there is some way, I think, you can... oh, look at that. Thriving towards fruiting. 2 plants. You can, I think, use a composter, which can turn plants or rotten plants, I'm not sure, I never used the thing, into, oh, already 2 potatoes, into, for example, volatiles, and I'm not sure if that actually basically creates gas, you know? I mean, since we're like creating new plants here, that would create new compost, which would then create new gas, so can that basically be used to create infinite gas? You can automate planting, you know? There are ways to do that, of course, too. Here's a pneumatic mining drill. It's nothing special, but you can see there's a slot for a gas canister. What I need now is a gas canister with gas inside. Do we have some gas? Do we have a gas canister that I don't need? That one. Let's just recycle that one. If I need another one, I'll just make it. Turn that on. But I think we have an energy problem here. Oh, motherfucker, we have an energy problem. My station battery is out? What draws all that electricity? When did that happen? Damn. But, well, that's not really a problem. We have tons of coal here, and we have our solid fuel generator, the thing that you start with in your lander, and you can also, of course, manufacture yourself. And that thing is ideal for the situation. A whole stack, why not? It's not lost. I mean, you saw that this thing doesn't really charge up, so if it now charges up a lot, that will not be lost electricity. We're not wasting anything here. But is this closed? Yes, it is. So any gas, what's in there is oxide. It's not something that produces water, it's something that produces nitrogen and oxygen. Any gas will not escape here. And now we have, okay, we already have 9 megapascals. That's something we have to take. Oh my god. Yeah, let's do that. Let's give you the greatest show on earth, basically. I put this in, 2 kilopascals. Now it's increasing and increasing. It will probably stop very soon because this thing is doing kind of breathers. And then it heats up again and then it tosses out more stuff. We're approaching 10 megapascals, 10,000 kilopascals. And that's the limit of what these bottles can take. And here we go. This is nature telling me, dude, you have a chance, you had a chance, I warned you. And I'm like, no, I do not. Is overpressure, see? Too much in there. Let's pick that up. You can see here a progress bar, which is about the health. And you see here a number that goes up. That's the progress bar in the form of a number. And I will just stay here and look at the plants, because plants are beautiful. Are they not beautiful? I think plants are beautiful. I love plants.
Mission critical. Health critical.
I happen to be dead. You are dead. Respawn? Yes, do that. I will, of course, reload the game, because the base was half destroyed, and I fucking hate that my death is actually a part of the reality that I have lived here, even though I might start, like here in easy mode, with all the resources that I originally had. And that's something I really dislike, and not about the game, but about this mode. I don't play this mode, therefore. Because I have my reality here where I get resources and all that, and all of a sudden I have now 2 tablets, 2 pills, extra bottles, extra tracker chips, and so forth. So let's reload the game. I want to show you how to work around a bug that the game currently has. Listen. Heavy breathing, and also my battery has 0%. What the fuck's going on? Well, if you have quit to main menu and then loaded a session quite a few times during one Stationeers gaming session, you will have that problem on the moon. I don't know if it's also on other planets. I think I have only observed it on the moon. And what's happening is that the chunks of the world out there, the parts of the world, you cannot see this right now, but I mean, I tried to see it. They are not loaded yet, and for some reason that means that everything is somehow fucked. And the way to remedy this is just press escape, give the game some time, and then continue. Okay, now we have our bottle here. Oopsie. Man, I was talking an ear off and almost exploded that thing again. Now we have basically the ideal setup. Where is the mining drill? There is the mining drill. No! Ah! Anger. Yeah, as you have seen, there are more objects, not just the mining drill and such, which have multiple click points. And, you know, the gas canisters can be opened if you click at their top. Yep, that's what happened. See that hole there? I think... Ah, yeah. Now you observed it firsthand. So let's try that again. Of course I can use the usual inventory click approach, but I want to do it like this. Okay, so I wanted to mine some silver. Let's do that with this nice drill. By the way, you can turn on and off your entire head-up display. Let's do that with F2. Now look how this thing melts the landscape. Even if there's ore, just be gone, give me that stuff, you know. But I'm looking for silver. Where is that silver that I had here? So all the silver already mined? Ah, sad face. Too bad it's night. Okay, let's pause again. Okay, I found some silver. Let's open the inventory of the pneumatic mining drill. There you can see the pressure. I mean, obviously I'm using up the gas. What just happened? Did I just get a full stack of silver by clicking once? Okay. Let's toss out that cobalt. It's only 2. Yeah, it's really fast. Anyway, you can see that the pressure is going down, but the pressure is going down moderately. So they actually gave you a great opportunity here. Once you have your furnace and you've made some steel, then you make some solder, which you have seen is really easy to do if you look at the Stationpedia and experiment a bit, which I have done, so I know right away what to do, but you can find it out yourself. That you can really benefit from that ridiculously. I mean, this thing is awesome. Also, you get to play with atmospherics, which was also the idea here. Because it's risky. Obviously, you can blow up your base. And then it is flat. Or even compressed to only one dimension. That would then be the baseline. Where is the base? Come on, don't tell me I forgot where the fucking base is. It was over here, I'm pretty sure. No! Oh. Come on, this is life. Live recording and then this botch. Apparently I fucked up. Is that the base over there? No. You can't see the station this far. So sadly. Damn it. Okay, I will pause again, maybe I find it. Is that some remnants of the station over there? Ah! Yeah! Seriously, I didn't know that would be the base, but some things are actually visible further out. You know, it's early access, so yeah. You have to live with some quirks. For example, the station becoming invisible so quickly. And there are some ways to work around that. Obviously, you can remember exactly your compass orientation. You can use the tracker module like I showed you. You can put up some large pillar here with lights on top. Yeah, various ways. Did not turn offable drill. Man, it's crowded in here. Wait, I don't have to smelt this. I can just make my Electrum right away. But while I'm at it, I can smelt some other stuff. Look at that, station battery is full. A full stack of coal did that. Probably could have used less coal even, and wasted some. Or maybe it wasn't topped up completely and the sun with the solar panels did the rest, I'm not sure. Go. Has it arrived? It has. Okay, let's make some Electrum. How is Electrum made? I think it is very low pressure, so we have to release the pressure here. Let's see, Electrum. Can we also just search for this? We can. So, temperature 600K or more. It's relatively low, but we're basically free here. And up to 2.4 megapascals, and currently we have a little more than that, and our temperature is still low, so I have to put some fuel in, which will in turn, of course, increase the pressure. So, yeah. Now let's do something stupid. See, this just evaporated in my hand, because the sun is looking at me straight away. But there's ways to circumvent this. Aha, now it falls directly into the chute. 2, 3. And on. Now we have enough temperature and a bit too much pressure. Now let's see, can I actually do something about that? I will try this thing with a tank in between. I've never done that, I'm curious. It is so crowded here. Can I put something away? By the way, here now that we have the tool manufactory, we can of course make more mining belts. And a mining belt is just the place that I need to store my gases, stuff that can melt. So you can not just store stuff more efficiently, but you can store stuff that you can otherwise not store. So we will have some more room here. What is the potato doing? 2 days. 1 potato seeds, 1 potato seeds. Replant instantaneously. Now these naked potatoes would hold 12 hours, and now they hold 3 days. Oh. Oh, what's that? Someone threw something nice in for us from the ceiling. Now isn't that a nice setup? If only that thing would turn on automatically. I mean, that sucks. I mean, I think it's a bit much that you have to program something to make that happen. Of course, once again, a challenge that you can overcome, so it might be intentional, blah blah blah, but I think, no. This is such a cool setup. Some chutes, put it there, turn it on, it sucks energy all the time, so that's a problem for a beginner with a small energy reservoir. So why shouldn't a beginner then be able to build this at the cost of having this energy use all the time? Okay. What is our air mixture doing? And the temperature? Okay, 37 degrees. Thriving towards fruiting? Why are they thriving towards fruiting in this climate? There's 2 possibilities. One is they have not yet caught up to the fact that it's warm in here. The other is that they have actually basically mutated. Of course, at an unrealistic speed, from plant generation to plant generation. But, let's take a look at these stats. Min ideal temperature 20, max ideal is 37. I think the max ideal by default is 30. Hilariously, 37 is our current temperature. Oh, it's not 38. It's increasing. We have some elimination stress, but there's nothing to stress out about. Put away. And do something cool. And maybe some cleanup? Can we do something about this quickly, efficiently? Is there some kind of magic trick? I don't think so. I purified the air between videos, so now we do not get this liquid stuff in here, so we can just keep pumping, and then now you hear that the pipes are expressing that they are about to die, but there's only a warning. They will only die at 60 megapascals, and before that nothing will happen. And we are not going beyond 50 megapascals here, because like I explained, the Here the internal safety is set to 50 megapascals per default on that thing, and internal again means into the pipe network. We can turn it off, by the way. So let's cool that down. We have some CO2 in there, obviously, and that, let's see what its freezing point is. Its melting point. It's a liquid point. Deox. We don't want to have anything freezing within our pipes, not even in liquid pipes.
Waste tank caution.
But liquid alone is also a problem. And we have 50 megapascals, so we have to go up here vertically. And then we see that at a temperature of 269 Kelvin, again 273.15, 273.15 is 0 degrees Celsius. 269 then must be like something like minus 4 degrees. So if we leave that in there until we have minus 4 degrees, then we will have we'll see CO2 becoming liquid, and then the pipes will start to stress out. And yeah, we don't want that. But the room is very hot, and there's a lot of gas in here. If I would put all that gas in those pipes, which I can't, then I think the pressure would be like 300 megapascals or 400 maybe. So we need quite some intense cold in here to cool down this 37 degrees room to something nice. You can also, of course, do multiple breathings, and later we should do that automated, which we can do with our IC10. So that will be a more advanced programming task, which I hope I will also get done. I mean, as part of this video series. Okay, temperature is diving. Now we have to remember, if I suck the pipe dry, the process will take some time. So if I turn this on now, just in time, that will actually be too late. Let's see what happens. Saving game. F5 is for quick saving. You can also do that here in the menu, or save as under a new save game. That is actually something I do as a backup fanatic. I save as every once in a while to have, with a counter, you know, 01, 02, 03, just because things can go wrong, and if they can, they probably will. Okay, where's my liquid CO2? Come on! Huh. Did I calculate that wrong? 269, 273? You see that the pressure is decreasing. That's because, there's our liquid CO2. Because, yeah, it's getting colder. So let's pump that out quick. Minus 10 degrees. I'm going to the other end of the room. Temperature is diving. I mean, using just the air conditioner, the portable thing, is easier, but it's, I don't know, this is more fun. Oh goddamn, it's getting too cold. How much is still in there? 3 megapascals. I could just turn this off, of course, and just leave it in the pipes, but guess what happens then? It keeps cooling, the pipes burst, I have to rebuild this thing. So this cooling approach is a bit risky, but the plants will cope. I mean, it's only 14 degrees Celsius. See, that was cool. The beginner portable things like the AC and the air scrubber are quite overpowered. So I basically try to not use them too much, because that kind of breaks reality a bit. I wonder if they will eventually nerf them a bit. Where was I? Room was cooled down. We want to make some Electrum. The the furnace, I left that open this whole time. I wonder if the pressure is now at 0 and we have to start over. That would suck. Pressure is, yeah, okay, that does suck. I failed. Okay, the sun's not out, it doesn't matter. This actually sounds fine. Let's toss in the stuff. Again, look up Electrum. It needs... See, this Stationpedia is not so much for reading up what to do, but for reference. Ingot Electrum needs half gold, half silver, 600, okay, and yeah. Ah! Oh, I thought I only had 40 silver. That would have sucked. It's not green, so something's wrong. Ah, yes, the pressure is too high. Pressure is decreasing rather quickly. I better stay here. Heavy breathing. Looking forward to having the wireless batteries. I don't know what substance we need for that, but I guess we'll make it. And then, of course, we will have the power problem again, because transmitting that electricity over the air takes wastes some energy. And now we have Electrum. Hooray, and a lot of it even. What did I want to build first? Let's check the agenda. Yeah, of course, the automation of the arc furnace would be awesome. Some programming, yeah. So we go here, and the toy soldier goes there. Oh no, let's just leave it here. And drink some. Food, I need food. Yeah, let's eat some of our feast here. Yep. Since I just changed some value down there on the screen here, my food, let's explain some of these. You can see the light is indicated here, in case you don't see it on the screen. And here we have the helmet, character I, the I key. Here we can see the internal pressure, the target that I set. You can increase that and decrease that. I think decreasing that can actually help you save on oxygen that you use. But this also means that the volume of oxygen within your suit will be smaller, and so any kind of wrong gas that you have in there, a buildup of nitrogen, for example, and so forth, will be more drastic. I mean, so you will feel that earlier. Here we have the target temperature, the current temperature, jetpack thrust, outside temperature 14 degrees, where I'm looking, my current speed. Yeah, let's produce that stuff. First we need the housing, and we need steel for that. And a place. Ultimately we need a place to plop that down. I have to think. What circuit? I only have one circuit here in my base. We have the outside heavy cable circuit, and then we have after the battery another electricity circuit, and then here starts the third one. And of course you can have a tree-like structure with several things in parallel. We just have like a river. This is the source. Then we have some kind of cliff here, and this is where we go fishing. So everything on this side of the area power controller will be one system, like I showed you here in the list, everything will be listed. But this also means that the chip that I use will have access to all the devices of my station, except for the station batteries themselves. Wait a minute, I want to show the station battery level on a landslide. That would be the first programming challenge that I wanted to try. Which would mean that I need an IC, a housing chip gedöns thing, here. So I need a second one here. So let's make 2. But first make the chip. IC10. Gold, steel, Electrum, solar. Let's make 2 of these. And then we go programming. When you do what I'm doing right now, you can actually get hurt, your suit will be damaged, and then you will be glad if you still have your inventory slot eating duct tape on you, at least outside, because then you can just hold it in your hand, press the right mouse button like eating a potato, so you can do that in little steps if you wish, or you can just keep pressing. It will repair the suit, and then you might want to do that again straight away, because I think the fact that the helmet is damaged and the suit means that you have to have 2 different repair operations. And this means the suit will be working again, it will be airtight, not entirely, I'm not entirely sure, sorry. But I think it is less stable, and this health bar that will appear here will of course still be low. And it might be that if the health bar is low, then the suit will actually be more prone to damaging in the first place. I feel to have observed that, but I'm not sure. We have 2 chips, okay, and then we want again housing. We only have 1 housing, we need 2, so that's kind of a housing crisis. I see myself out. Here's the exit. Let's space myself for this. Yeah, okay, here's the arc furnace connected to this circuit, and I actually don't know. That's interesting that we are in the same shoes now, because you don't know how to program, I guess, and I don't know how to program that thing, and so we'll have to look that up on the Stationpedia. Where will I place that? I can place it over here to do that simple task of restarting the arc furnace.
Power critical.
And I can place another one over here to do that cooling thing automatically. But you know what? That will be short code, which should all fit on 1 chip. So, yeah, let's do that then. Where do I put this down here to express intention? See, this is the housing. You can turn the chip on and off. When you turn it off, it will just not have any effect. And when you turn it on, the code will start over. So if you have a list of commands in there, they will be executed from the top. Usually you have some commands at the top, and then you have a loop that just keeps going forever. And so if you turn that off and on again, or pull it out and put it in again, let's do that, then in both cases the code will start from the top and then re-enter its main loop. Okay, we have data connection and we have power connection. In many cases you can just connect this all together. Sometimes you might want to power this from... Actually, you know what? Yeah, we could, for example... yeah, let's look at this. Here we have the generator, the solid fuel generator. And I could actually go and say, when the station battery is below 10% or whatever I choose, then turn on that thing. And once we have reached 20%, turn it off again. That's what I've done in some worlds, and it's easy to do. But the chip, the housing, needs to be powered, and it needs to have a data connection. Let's assume that this thing, the generator, would have its data and power connection combined, which it doesn't have. That on the right side is the data connection. If it would be combined, then I couldn't just plop the chip down and connect everything with that cable there, because that would mean the chip itself, the program that needs to be running, would only have power while the sun is out or while that thing is running. So we would have to pipe the power into that chip from a different circuit, from this one, for example. And then now you see why the data connection is a separate outlet of the chip, because the data connection then could be go over there and connect there. But that's unnecessary anyway, since that thing has a data connection that is separate. Yeah, the program is running. I mean, there's no program yet, but it's running. If there's some programming error, you will see flashing here, and then you can point at it, and it will tell you which line has the error and also some description. So, yeah, you're not entirely blind. But how do I program the chip? Well, I need a computer. Yes, I do. So, let's see what that takes. And instead of a computer, you can also use a laptop, which is more convenient, therefore probably more expensive. Iron, gold, copper, 5, 5, 10. Gold, copper, steel, electrum, solder. We have all of that. You know, let's make a laptop. Let's go fancy. Oh, I think I realized something unpleasant. To make this thing, you need electronics printer tier 2. Guess what? We don't have that fucking thing yet. Can I upgrade the electronics printer now? What does it take? It takes Constantan. We don't have that yet. Should we just try to make that in the smelteria and go laptop, or put some big bulky computer somewhere in here and then we have to run over there every time? I would say it's the former. Constantan. What does it take? We need copper and nickel. I have both. Same amount each. We need basically high pressure, and the temperature is also kind of no one gives a fuck. So let's make that then. Where is my stuff? Oh, the light went out. Aha! There's a 32 nickel. Is not too much, but it's good. It's enough for the purpose. And then I need the same amount of, what was it? Copper, right? Copper. Okay, the same amount of copper. Splitting it like that is not advisable. You should empty your hand. Also, you can split in half and do some back and forth tricksing. Damn it. I keep forgetting to open my helmet. And because I keep forgetting to open my helmet, I will remind myself of just that. Oh, no space anywhere. Crap! Ah, okay, that can also not be used, then... Maybe that'll do. Labeler, where are you? There it is. Oh, that's not good. Exclamation points have this nice parallel jump into your mind and jump into your eyes effect, so let's do that. Where is the stuff that I need? Did I toss that somewhere? Damn! Oh, unnecessary. I would like to rewind the video to check where it is, but I can't. Can you tell me? You could rewind it? Yeah, it was safe to assume that this thing has still some pressure and heat going on. Okay, we need 1000 Kelvin and 20 megapascals. So let's up the pressure. The sun is up, so that's a bit tricky, but we'll manage. Ow! That's interesting. I never had that. It got stuck processing right there, probably because it just went too cold. Interesting. 17. Oh, I don't know what's happening, really. I think it will open up soon. What the fuck is happening? Okay, pause video. Yeah, that bug. Okay, press escape and wait it out. It actually turns out that I seem to have run into a bug in the game. There are some, but you know, I have never had this problem in over 600 in-game hours. So that's really... what I assume happened is that this thing actually went too cold in the middle of processing, and then it just got stuck, and no matter how often I clicked this, it didn't help. So I will just heat it up a little before we go there, and then that should not happen. Actually, you know what would be more interesting? I would just try to repeat that. Let's repeat the bug. And to see if that's actually what happens. Repeatability, reproducibility. Very important for bug hunting. And now it's stopping immediately. Maybe it's because I waited so long before actually tossing it in. So it went even colder. Huh. Hey, look at this, 371. It might be that 100 degrees Celsius is kind of the lowest point for ore to be processed. And yeah, now I could click this a million more times, but I will just reload. Okay then, let's heat that thing up. Two volatiles, one oxide. Two volatiles, one oxide. Let's see how far we've come. Oh, it's already burning. 11 megapascals, not enough for the purposes. Now let's toss that stuff in. This time it should work. Because, you know, this 100 degrees Celsius thing is probably indeed what happened there. Aha, now it's working, but we don't get our Constantan because the temperature is fine, but the pressure is not. To have more pressure, we can do multiple things. We can just put in more fuel, and that's what I usually do, because then I don't have to think. Don't have to try it out. The one way that works is usually the way I use. That's a bit sad, admittedly, in a game like this. Okay, 20 megapascals was the limit, I think. Yeah, okay, Constantan, thank you. And we can just leave the furnace like this because, you know, you see the pressure is not actually increasing, and if we come back in like half an hour real world time, we might still have enough pressure and heat in there to do something meaningful with it. So it's always good to leave that thing on. Constantan, what can we do then? We can make the schlepptop. Okay, not while there's gas streaming. Ah, the mod, right, I need the mod and then I can make the laptop. So we can actually mod our devices now. Right? We can mod all of them. Yay! the second IC housing would later go here. Or it would go here now. Okay, that's what happened. We only need one mod. Crap, where did I put the cables? Oh, it could be that I just used up all the cables. Now the electronics printer is occupied, but as I learned now, we can produce cables here too, if we have the copper to do so. That stupid thing. Electricity. Looking good. See, the big station battery is a monster. And actually, you know, that station battery is not even the big one. The actual big one is 3 times as high and has a little bit more, I think, than 3 times this charge. Or was it a little bit less? I don't remember. Can be looked up in the Stationpedia. And these things are really monsters. Also, they can be put side by side. These ones can also be put side by side, but here, look, you have to turn it on first, and then you can't turn it on or off, you know. I never turned them off, but you have to turn them on, and if you do that wrong, for example, if I start building in a cramped base from the right, then how will I turn that on? Well, you can use logic. You can use MIPS programming, you know, IC10 assembler, or a logic chip to change the on-off state, and this will actually also change the physical switch. It does that for all the devices in the game. It's very nice that this is a one-to-one relationship. Are we done? Is it finished? No. This thing will be used to show us the state of our station batteries, which is a good opportunity to actually add a second one, so that what I'm trying to do here makes more sense. So the next thing I would build is the diode slide. Right, that was part of the kit lights. Okay, a bit about programming. The IC10 programming assembler. Okay, let's not talk about that then. That was ill-timed. How do I assemble this? I think with a screwdriver. Yep. Now the electroprint is advanced and can make, for example, the other mods. Should I make them? No, it's an ideal opportunity to go programming, because that takes time. In the meantime, it can print the stuff. We don't just need a computer or laptop, but we also need the respective motherboard, which is a bit different from real world, but this is space, you know, we're astronauts, so we have dedicated, hardened equipment that is really good at its job, that doesn't break, but it's focused. So for this thing, then we need a chip programming board. I don't know what the exact name is. You can just look that up. I say board, and here it is. A sorter motherboard, IC editor, that's the one. Logic motherboard, communications motherboard for contacting traders and using the radio dishes. Stop! I don't need one. And what else do we have mod-wise? Let's start with the auto lathe mod. Moving up in the world. No, wait. That first. Okay, we have a laptop that we can just carry around in the inventory. We can open it and close it. And it has an inventory for the battery and for the motherboard. Let's try that thing out without motherboard. Where is a battery? Should I just make another battery? Needs copper. does the wireless battery cost, by the way? Because those are of interest, aren't they? Gold, copper, steel, that's all? Dude, why don't I make those? Let's make those. I have enough gold. Steel, I have enough. I can smelt more steel. Okay. Did I just make 2 batteries? So now we have 1 wireless battery here. And that's what that looks like. I only need 2 for now. But they wouldn't charge this way. I need also something that transmits the energy, and that will be the Omni transmitter. Gold, copper, steel. Should smell some more gold. That would be so awesome if that happened automatically, right? So the Omni transmitter will not just consume electricity for charging the batteries, because that respective amount of electricity will of course be used, but it also has some base energy consumption, as in you turn it on, it consumes energy, and I assume it will also have some loss energy from the transmission. Also, the further away you are from that thing, the less energy you will receive. That all sounds very, I don't want that, but no, you want wireless batteries and the Omni transmitter, you do want it. Let's put this up somewhere. Where will we be most of the time? I'm not sure, so let's put it up just here in this corner. Or I could put it on the roof, actually. I'm gonna put it on the roof. That would be a good opportunity for us to smelt more stuff, whatever that should be. But the gold isn't yet done. We would have learned about that. So let's do something until then. This device with a battery. Wanted to use the wireless one, but they're not charged yet. And it's not showing anything because the board is missing. And here we go. That's it. Toss it down and use it. Here we have something that we can click right from here. Maybe I want to put it on it. Can I actually screw this on the table? I'm not sure. I think that's missing.
Suit damage.
Okay, I don't know why that happened, but it did. So let's roll with those punches. Where is my repair kit?
Waste tank critical.
Yeah, what just happened is the suit was leaking, and since it tries to uphold a pressure of 100, while the pressure within we find ourselves is 80, the suit leaking meant that more oxygen had to be pumped into the suit, and so actually I wonder why that also meant that the waste tank was filled. Was it just a random coincidence? Let's enjoy once more the gas simulation. CO2 level is now a wee bit higher than before, but we think it's within reason. So we are living in a nice symbiosis with our plants. Where was I? I forgot what I was doing. That suit. Oh yeah, right, it got damaged here. Yeah, that's probably what happened. I lifted this thing up and it bounced against that and against that and against that, and the physics simulation somehow built up too much energy and bounced it into my face, which was protected by the suit. And so the suit broke. God damn it, this is stupid. I can't get... Can I not get over this cable? No, it's not the cable. Okay, that's what that looks like. So I can plop this down and you will see the devices that I can address. The laptop itself. That's because we have the circuit board, which can also be put into the computer that you install in your base, and then you can choose which IC socket you use. This one has a built-in socket, so that's the one that I can address, none other, because it's not connected to anything, and I don't think actually I can connect the laptop. Okay, then we can just start programming right away, or we can pull out the chip and put it in here and start programming like this. It doesn't matter. Because what really matters is these two buttons, and you really do not want to confuse these two buttons. Absolutely not. This reads the code that is on the chip, it imports it into the computer. This exports the code that you have in the computer onto the chip. And if you think about that a bit, you will realize that clicking the wrong button in either case is always a shit situation. Is it still fucking smelting up there? Okay, code editor it is. Oh, I wanted to produce something. Right. Auto lathe printer. Now we can go smelt something and set up the Omni transmitter thing. Okay. And I forgot the helmet again. Yes, yes. If there was some button that I could push to actually push myself down in low gravity, that would be so awesome. Low gravity can be really annoying, but I think that's intentional. You know, there is I don't know how to pronounce it, MIPS, which is another barren rock on which you can play, and that has a really low gravity. Look down there. I will decrease the field of view. See, the wireless batteries are charging, even though they're just tossed on the ground. Isn't that awesome? How do people play with such low FOVs? I don't understand. They're still charging? What? Oh no, they're not charging, right. The blinking means that it has a very low energy level. It doesn't mean that it is charging. Once it is red solid, it means they have charged a little more, etc. Just like all the other batteries.
Power critical. Power low.
Haha! I will just run myself on the wireless battery now. And also the tablet. It's most reasonable to run the tablet and your tools here on wireless batteries, because you will rarely actually use so much as to use them up completely. The exception is the arc welder, which we haven't yet produced. That's a welder that doesn't use gas but electricity, and it uses lots of it. And so a wireless battery, even the supposed large ones, which are actually not as big as the large normal ones, they're, I guess, maybe about as big as the small normal ones. You know, the large wireless battery in the arc welder lasts a few welds and then they're done. But depending on where you do that, that would still be a reasonable choice to make. Also, you will have more wireless batteries on you, right, in other devices. Then you just swap that out. Eventually, you return to base, and then they will all be charged, and it's, you know, fire and forget. The problem is you have to see that your station has enough electricity. Electronics printer mod, pipe bender mod. No. Tool mod first. Need more steel. I need more steel. I want more steel right now. Now I need the stuff on me to make the steel. And steel is one of the big ones that you need all the time. So I will just make a lot of steel right away. We need 1 stack of coal each for the amount I want to make, and we need 3 iron each. 1, 2, 3. Because once the tool printer is advanced, we can finally make the advanced belt, and then inventory handling will be so much better. Current pressure. Temperature is too low, we have to put some more fuel in for the purposes. I'm not sure if tossing in the stuff will lower the temperature significantly. Well, we don't want to go there again, right? Fill the hands. That should be enough. 1 jump of fuel. Or maybe 2. If you're standing in the wrong angle here, what can happen is that you actually smack your suit, and then you need to repair it. That sucks, of course. The reason that we just heard that is that I stupidly tossed something on the ground, and so we had some gas pressure, and so we have some audio transmission. Yeah, that can also happen, it's also a bug. If you have to do the timing just right, it will not close the chute. I have no clue if this can actually ever happen if there is some chute network connected. I assume no, because I would have heard of that by now. Oh! Huh? What's happening? Why is this not complete? Did I not put in the right amount? 150 iron, 50 hydrocarbon. Pressure 20 megapascal, temperature too low. That would be the reason then. I think it's too cold again. Yep. You will notice that this thing is still super bright, which I think doesn't just express heat but also pressure. If this would be in atmosphere, you would also hear that it's super loudly rumbling. I will just demonstrate that by tossing down some gases so we can hear that thing. Then I will turn on the arc welder. Because of reasons. Okay, we're back. Yeah, the pressure keeps building, and there is something to consider. This is actual substances in there now, not just pressure from gas having expanded due to heat. By the way, I said arc welder, of course that's the normal welder. The arc welder does not ignite the atmosphere, except when you use it, I think, but you cannot just use it like that. So actually, while the arc welder is pretty awesome, you can't use it at will, basically. Interesting, you have to have, like, for example, a frame and a sheet with you to use that effect. Interesting. Bum, bum, bum. Bum, 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 bum. Yeah, steel. Yeah, let's ignore that thing. Is the pressure still building? Basically not. Okay. Our station battery is discharging. We have to do something about the power. Maybe I should produce a solar panel. Now when you just type solar, you will easily go and produce the wrong ones. I have done that so many times at the beginning. So it's best if you don't search for that, search for basic. Basic heavy means it's protected from storms, I believe, and basic is what I use on the moon. There are no storms here. Should we make 2? Do we have enough iron smelted? We don't have enough iron, period. We have enough iron. Okay. The fucking tables, let's put them away. Let's table those. Oh, 2? Oh. Contains product placement. So I can just go and smelt all of these together. Can I produce the other mod? What did I need for that? Tool printer mod. Yeah, perfect. Because now that the furnace is still hot, let's just toss the iron in there. So we have the ingots right away because it's so fast. But the thing is, as fast as iron is to smelt in the arc furnace, it needs relatively high temperature in this furnace. I mean, the copper takes quite a while in the arc furnace, and so does gold. But both of them can easily be tossed in the normal furnace when it's a little bit colder. This needs 800 Kelvin, but copper only needs 600, and gold also needs 600. What's the temperature? 800, so I think we can get that done. Let's turn that on. There's no risk here if it dips too down, dips too low with the thing being open, because we're not doing any mixture here. I mean, so if they would be too cold for actually producing the ingot, what would come out is just the ore again. And I'm not sure, but I think the ore would then be degassed. This means that the gases that come with it when you dig them up here would be in the furnace. That can actually be very useful. But when you dig ore from the ground with a deep miner, and then when you toss something in the centrifuge, which you have to do with that stuff, what comes out is degassed. So you cannot benefit from infinite gases, sadly. I forgot to set up the solar panels. But I need glass anyway, so... Where is my glass? On my nose. Yeah, there it is. And the pipe bender mod. Yeah, let's do that. Let's make... Yeah, the modded tool printer. Let's make a tool belt. Tool belt Mark II. Iron Constantan. Do I have Constantan? Yep, and it's currently in use, so let's do that later. These machines, by the way, require more electricity when they run, so you should really turn them off when you don't need them, when your station is still such short-dicked. So, I forgot something, the heavy cables. Damn! Also, we don't have space. Not good. What to do? Normally I would go for steel frames now, because they take much less resources, less than half I think. But I don't have a steel stack now that I can use. without taking it out of the machines. I don't want the hassle, so... Heavy cables. I know I have some, at least one. There it is. One cable, that's not enough. Heavy cables can only be produced with this thing, so we have to wait now. Has been upgraded. You can see that from the slow booting process. Needs upgrading. Is upgraded, as it couldn't print those. Is upgraded. So that was actually the last one. Convenient. Heavy cables. See, these space problems will soon be a thing of the past. Give me the Constantan, please. And give me the advanced stuff. So that thing was on this whole time, but for some reason didn't consume any electricity. I think there's a bug here, or maybe they didn't put in some electricity use. Possibly they were debating internally, hey, how much electricity should this thing use? I don't know. So they just left it out for now, because imagine you're typing something, programming something, and then the power craps out. You can close the editor with cancel or with OK. So if the power craps out, what effect would that have realistically? The cancel effect. Then you lose your code. They didn't want to put that on us, so they didn't yet decide to reduce the power of the battery. Is my guess that's what it is. So tool belt Mark II and the mining belt Mark II. Now behold. This is my tool belt, which I will hold in my hand, and there's the new tool belt. Somewhere here. See? Much bigger. Now things get more relaxed. And I always order my tools like this. Crowbar, and this also destroys and dismantles stuff. Screwdriver, and this thing also rotates. Wire cutter, and that's also something like that. And I usually take the labeler with me, which the further you get into the game, the more often you need it for programming, for example. And then, of course, the cables. Where are the small cables? Oh. Didn't I have the small tool belt in my hand just now? Damn it, that happens way too easily. So what to do with that thing? We recycle it once we have the recycler. I just don't remember where the fuck that was. And the mining belt Mark II. Let's see what that one does. A little bigger. Same amount of tools. And a whole extra row for ores. Okay, so much for this. Set up solar panels. So as you can see, this base is a bit cramped. And did I ever make a base like this? No. I have made like 10, 20 little or longer games, playthroughs, and every single one was different, usually even significantly different. So replay value is not just high, it's just 100%. This game is ridiculous. Best game ever made. That's what I thought when I played Astroneer, you know. A year later, I played this. Don't tell me. Sometimes when you come home into your base, you will find a huge pile of heavy cables that you made because you did two things wrong. You forgot to turn it off, and also you didn't use a stacker, which would make a neat 50 stack of that and then spit it out before it starts to build the next stack. However, the mistake with the stacker is a mistake, but the mistake to have accidentally like 100 cables instead of the 10 that you intended to make, that's not a mistake at all, because you will need heavy cables, and some more heavy cables, always. You can't have too many heavy cables. The only reason not to have infinitely many right from the start to build many is resources. So let's come home to a surprise then. When the sun comes back up, we will have 2 more solar panels, which I hope will outweigh our Omni transmitter load, maybe also the load from the advanced manufactories, since they're not actually running the whole time. So to make sure that everything is wired up, you can use the network analyzer. Maybe I should show you that thing for a moment. It's a bit cumbersome to use because it doesn't combine... Where is it? It doesn't combine the individual items into one, but it lists them one by one. And if I would show you my Vulcan base, where I just went with wind turbines, that's like 130 wind turbines. That's a long fucking list. So pointing at the cable now shows me the cable network identity. That's just a random-ish number that the game engine thought of. Same for the pipe networks. You can see here the generator, solar panels, and the station battery. These are on this network. When I look at this network, I see the IC housing, the area power controller, and the station battery. So everything just like I described. Cables. And I realized that this was an excursion from another excursion. What is it that we were doing? Yeah, programming. What did we want to program? No, I wanted to use the wireless battery in the laptop or in other devices. No, I'm doing that already. Should we start with the programming then? I want to see the station battery state. I will start with that because that is not new territory for me, so I can explain something to you while not being confused myself. Where is the light? Now we can also make grow lights because we have Electrum. Yeah, this is quite the reminder of Helmet. And my air tank is empty. For convenience purposes, I will just dunk it in here quickly. You saw the pressure decreased further. So my tank now also has less fuel, less content than it had when I did this earlier, because it's just pressure equalization. There's no pump in play. Iron. So it's plopped down the diode slide, which would then of course also show up on my network analyzer. LED, wall light, there we go. That's a nice place to put it. So I can see the battery, it's not in the way, and it looks kind of like as if I'm looking at the battery. Nice way. You can combine heavy and simple cables, by the way, in one network. It's not a problem. You can just, you know, this could be a heavy cable and this could be a simple cable, or vice versa. That's not a problem. You just don't benefit from that. Ah, crap, I didn't look right. I just goofed. You hear the sound of the APC buffer battery discharging. You hear the sound of the battery charging. So, this thing is on, this thing is off. Where's my laptop? I have it on me. Turn off the light. Do I need to eat something, maybe? What you can do while programming is you can just pause the game, like in the Stationpedia. But I think it's nicer to keep the game running. Also, we would like to get a feel of our new energy situation, and the best way is, of course, to let the sun do its thing. Oh. Oh, yeah, I wanted to make another station battery. Nope. Also nope. Kit battery large. Needs stuff that we cannot yet make because we don't yet have the advanced furnace. Battery. Kit battery. Copper, steel. Oh, I don't have any copper. Smelted. By the way, if you place the arc furnace or other such things close to the window, you're actually capable of pushing the button through the window. And
Oxygen
admittedly,
low.
I do that
Low
sometimes.
pressure. Oxygen critical.
Whatever. I Tom Cruise this. Oh, we had copper. Hilarious. Only one, please. Station battery. Yeah, let's get into programming. I will first type out some stuff because I will probably type stupid stuff if I talk meanwhile, and then I'll explain. Where's my labeler? Okay, I will name this diode slide this name, and this name is also being used in the code. That's actually unnecessary, because the command that I will use here to read out the value or to write the value will be one that I will use one that will actually name the device instead of just saying I want that type of device. We could use just that type of device in this case because there's only one of these on the network, but that's unclean. I want to be safe from some kind of future blunders, and that introduces programming errors potentially. Right? I mean, later I put up a diode slide on the same network and then suddenly this thing will operate that other thing. I don't want that. Let me continue first and then I will explain. Ouch. Does that do the trick? Not sure. Export, don't import, otherwise... Fuck! Oh, I'm using the wrong chip. I think I just swapped them. When I point at the chip here, I can see 0 bytes there in the tooltip, and here I see 510 bytes. That tells me there's some stuff on it. Now let's turn that thing on. That doesn't look too promising. I possibly did something wrong here. But what I expected is, I mean, that this thing turned on, that's good, right? But I expected it to also show us some kind of progress value, you know, like, just like the battery out there, we would have some kind of 25, 33-ish percentage filling here. And so, let's... I would put up the next station battery soon, but we will do that afterwards. So let's explain what I did here, and maybe then I will also see the blunder. That's a good idea. Okay, this up here is the preparation for the code that will be executed below. The code below, as you can see here, uses words that are also up here. These words have been defined by me up here. Before that, they did not exist. These words represent a number. The number is something like 1275968 or something, or maybe even negative like that. And that number can represent a type of device, which it does in this case. It represents any and all station batteries of this build type, not the large station batteries. They have another name. I think the name is structure battery large. Actually, let's look that up. F1 battery, and then we will see the station battery here, and we can see here the prefab name is structure battery, and that is the hash. That is basically the number that I get into this word that I made up by calling for this word. Did you hear that again, this hissing? I have no clue what that is. I've been hearing it through this entire series from some directions, and I think it's somewhere over here. I don't know what it is, where that's coming from. Is that the tank, maybe? Whatever. So what you can do here, you can click on that word, and then it's copied to clipboard. That will reduce the probability of typos. Now we'll select that by double-clicking, delete it, and paste. This is probably what I had before. Let's test that. I cancelled. Paste it here. No, not like that. It looks the same, so I did not do that wrong. So what's happening here is I'm defining that the word CLS-BAT shall be the number that would refer to those batteries. Of course, this number is then just a number. The context within which I then use that number matters. And what I'm doing here is I'm saying, oh, you actually have some tooltips here. I'm loading a value into a register. Okay, what's a register? Let's say I want to okay, let's go with this one. SDB setting R0. What does this do? Here we have our IC housing, and when I point at it, I see the state none. Not a number. And that means that the value that I wrote into this thing, which I just did, is actually, yeah, it's not a number. So such a value holder can hold a number, but can also hold expressly the information that it is not a number. For example, when I divide 0 by 0 or anything by 0, the outcome will be not a number. So this statement here Stores register value to logic type on device by housing index value. Okay, in simple words, it means I am storing a value in a device. The device I can name here. DB happens to be the device that is on which I am currently running this code. Let me show you something. We have our nice atmospheric device here, and this actually has a slot for a chip, which I personally never used, but it's a very good thing to use, I heard, and I have to try that at some point. The reason that I never used that is that you then also have to deal with the concept of slots. Slot, you know, and I haven't done that yet either. So that would be, if you program a code, some stuff, and put the chip in there, and then you address the device DB, then you will address that atmospherics device. And here I'm addressing the housing within which this chip then runs. Store in the housing a value. Which value do you want to store of the housing device? The setting. And what value do I want to store? The value that is stored in register R0. These registers, we have 16 of those, 0, 1, 2, 3, and so forth until 15, are just value holders, number holders, numeric holders. There are no texts in here, only numbers. I don't have to use the name like that, the register name like that. This is also indeed not advisable. Instead, you should do this. Alias. What name do I want? Now I can just use this word as an alias for that register. So I can load this is not, see, okay, the L and the S statement are mirror partners. They belong together. The L statement just loads device type blah blah blah, and this saves device type blah blah blah. And the LB means load batch. There are also logic chips. One of them is the batch reader and batch writer. This means that you can read from all devices of a respective type at once. So when I say load batch into the register battery charge from the class battery, you know, the type battery, the value ratio, and how do I want the batch values to be computed? I want the average of those. Then I get, of my whole stack of batteries out there, just the average charge. That is what this does. Load as in a with load batch. Well, let's try that again. LB. Now it wants to know which register, but this register, which I'm using the alias name of. And then the device hash, which would be a number, but again I don't type a number here. Instead, I write this. Now, some people object to this approach. Some people prefer to just put the number here, or maybe not here, but at least up there. But personally, I prefer this approach because these numbers, no one can memorize all those numbers. But I can easily remember the concept of structure and then structure battery large, structure diode slide, blah blah blah. I can easily remember that, and so that's what I type up here without having to look up stuff all the time. So, load batch into the register battery charge from the type battery, because it's a batch load, right? The logic type shall be, now I have to check if ratio is actually the correct thing. So station battery, if we scroll down, you can see here what values there are. Charge, for example. I read the value ratio, and that was probably just the mistake that I made. So let's go here and instead read, where do I have to go? Here, let's read the charge. And then I write that into the housing. And what I'm doing down here is, let's explain that first. Oh no, let's first see if that now works. Now let's not confuse chips. I better put this one away. Go here, export. And what is the error saying? Currently flashing an error. Nothing specific. Okay, that didn't work. What's my mistake? Maybe this thing has a different name. Structure diode slide. You will also run into names like this, structure diode slide and such, which are too long, so they will be printed out as ... and then you can't copy them. That's a current bug in the game. Also no typo here. What the fuck's my mistake? I mean, I have done this so many times. I can basically sleepwalk this code. But obviously now that I'm explaining this and showing this, I have to run into some kind of stupid shit. What is the reason? So here I go and say SBN. I already explained what L and S means. L and S can load directly from a device. And I think that you can actually... There is a new type. I'm not sure what the command is where you can actually... I mean, every device in the game has its own unique number. Just like the cable networks and the pipe networks will just get some kind of random-ish number that will then stay with that thing. And you can use that, for example, in your code here. And then you can load directly and store directly in a device. But I haven't used that yet, and so I'm still using this approach, which is possibly also more sturdy, where I say I define first the type of device from which I want to read or where I want to write, and then I also define the name. And then I use this statement, which stores batch named. So I'm doing the following. I'm storing into the device hash, so that's the device type. And then the name hash, you know, remember I renamed this thing. So I will address all the devices that have this name, so I can have 2 diode slides in this network that have the same name, they would both be addressed. And then I can say, turn that thing on. What I can also do, let me just demonstrate that, is I can, see, I can turn this off, but the code will turn it on again, because that's what it's supposed to do. But I can say lock here, which will mean that this device is no longer human accessible. That's what can happen to your airlock doors. Let me just show you that. If I use the crowbar, unable to force open, door bolts are locked. That is what happens when you do what I just did, you know, you use the lock command, or that's also what the airlock board does. So the airlock cannot be forced open in this state. So if you're out of battery, you're out of luck. So it's best to always have, you know, an APC in here with a battery, so you can swap out the battery. So what's my mistake? What am I doing wrong? Define class battery, structure battery. Then load batch. Right, we actually have some debugging means. I can look here at the IC housing. We get not a number. So I'm doing something wrong from the get-go. My mistake is not down here, where I store something, where I try to store something in the diode slide. It must be up there. But I realize I want to show something first. Export. Yeah. Cannot interact as the device is currently locked. See, now the device cannot be turned off by me, even temporarily. And that is something you have to weigh carefully. Maybe it's not the best idea to do that. Depends on circumstances. For example, if I have a pipe analyzer that is something that you wrap on a gas pipe, or a liquid pipe analyzer on a liquid pipe, and that can be read out by a computer, and then you can by a chip, and then you can see what the pressure is and how much of this gas is in there, if there's combustion going on within, and stuff like that. So we will probably use that later to automate our station cooling. Alias B charge of where is my mistake? Let's turn that off again. I have to actively unlock this now, like I'm doing here, because if I just no longer write lock 1 into that thing, that doesn't mean it will be unlocked. It just means it will no longer be actively locked by the code. Now I can remove this line and just forget that we ever had that in there. Okay, as writing, let's see that again. Store in dB in the value setting, I'm absolutely sure that this is correct. That register value, so there was no mistake here. Here I'm saying load batch, battery char into the register from the device hash, the charge, and what should it do if it encounters 2, 3, 5, 100 values, because I have so many hits, so many batteries on this network, then it shall add them all up, or multiply them. Is that possible? No, it's not. Or average. Or min. stuff like that. So, average. What is my mistake here? Oh, I think I know. I mean, the dumbest mistake ever. Look there. I don't have the data connected. The code was alright from the start. Oh, did I forget an error? Anyway, we have that, we have this. We are defining this alias. By the way, someone showed me a nice trick on Discord. Really a good idea. If you use this alias feature, start with the high registers first. Because now you no longer have to remember in your head 0, 1, 2, which is rather easy to remember. Not so much as 15, 14, 13 seems a bit cumbersome. Because then you can still use some temporary values and just program those directly into R1, R2, R0, and so forth. So build down from here, and then some temporary values which you only need for a moment. You can use these. You can also, of course, just name them. Doesn't matter. Okay, define this, that works, everything works. The only thing that's missing is that there's no data incoming. So we are reading from this charge average, not a number. Okay. I'm not sure if I changed something. Let's just export. We see that the battery is discharging, so we are kind of in distress here. I have to put up more. That was this thing, right? I guess it's just some kind of entertaining effect that they added to this thing. Even though it's closed, sometimes it says, hey, I'm a gas bottle. Let's... Do I still have some frames that I don't have to make now? I think so. Yep. And some more solar panels, please. Quickly, as long as we have energy. Kit battery, also a nice thing to have. Basic solar panel. How many can we print? 4 regarding iron, many regarding gold, 3 regarding copper. Let's make all 3 of them. Let the time of plenty begin.
Oxygen low.
Yeah.
Oxygen critical. Low pressure.
Is still blinking. So, first thing we should do is let's fix the code, basically, by connecting that cable. Now that there's also a data connection, we can see something that also doesn't look right. What the fuck's happening? Okay, I must be doing something wrong. Why is that thing white now? Let's point at the housing and see what value we have here. Ah, okay, I was right to use the ratio. What we now have is a value that is the actual charge in watts for whatever reason. It should of course be joules. You know, yeah, something about units. You would probably forget that if you don't already know it. Out in one ear, out the other. But watts, that's 1 joule per second. Joule is the amount of energy, and watts is an amount versus time relationship. So the batteries, when they're idle, they of course have a charge, and the charge is of course joules and not watts. But you know, also I think they use watts per game tick, which is half a second, while in reality it's per second. But anyway, that's those details. You don't need to bother with that really. Okay, ratio. Damn. Export. And here we go, that's our current charge. And now we can see what the actual charge, the ratio is. You can see that the sun is actually doing us some favors, but that still doesn't, I mean, you see that the number is growing. But you can still not tell what that means regarding a whole day cycle. I mean, overall we might be in energy surplus, or we might not be. Doesn't matter. I'm currently making some solar panels, so that problem should be solved for the next few videos? I don't know. Can turn this off. It cannot turn itself on again, even if I'd program it so, because the program would be running meanwhile. Actually, this thing doesn't have to be on. because I can still see the ratio when it's off, apparently. I don't know if the ratio can be written to while it's off. I don't want to try that now, it's going too far. I assume so. Why would it refuse that value? How nice it is to have enough space. Okay, solar panels. Do we have enough glass with us? Yes, we do. Enough cables? Maybe. And then put up the station battery. Ah, crap. Fuck me sideways. I don't have enough iron sheets. I think we need 2 for the station battery, and if I want to put up 6 frames indeed. That should be enough. I don't have to build this row too, so let's just continue here for now. Immediately it's producing this and this many watts. It just said that it is not damaged because if there's a storm and this thing is damaged, one of the ways to repair it is to hold glass in your hands and yeah, point at it and click. This will be a long process, it's not very fast, so you would really try to not get your solar panel damaged in the first place. Okay, we actually are benefiting from all of them still, even though the day is already dying, but you know. And now the battery should be charging. Let's see what that looks like in our little numeric display. Actually, we should put up a LED display so we can see the number live. That would be nice, right? Let's do that next. Here we can see 20. Okay. Oh, fuck me. It's already discharging. We're already using more electricity. I guess the Omni transmitter is using quite some energy. That was an expensive choice. So let's prepare for some more solar panels even. And also maybe burn some coal. And put up another station battery so we can do that less often. Didn't I have some copper ingot lying around somewhere here? This station is so cramped. Ah, come on. Here we go. I can make... That would be 2 additional solar panels. I could stuff in some more iron now, then it would be more, but I don't want to burn through the resources so quickly. So, put up the next station battery, and then we will see that this ratio that's being shown there will nosedive, obviously because the overall capacity that we have is much higher than, and so the ratio of what we have is lower. Now, where to put it? It would be nice to put that horizontally here. Actually, that would be nice. I can also stack them, you know, just put it here, and then you will have some visible gap in there, and that's kind of unrealistic, and you can wire that vertically, but, you know, I feel like doing that horizontally here. Problem is, I cannot turn the fucker on then. So, what to do? We will use logic, of course. This station battery is not turned on yet. but we can turn it on. Oh shit, I don't have any cables. I realize I'm casting a lot more, but that's how it is then.
Waste tank caution.
Connected, and if I put in some coal, which I don't have on me, then I would see that one battery is charging, the other is not, because it's not turned on. So that I can see whether my logic that I'm about to implement actually works, I want to put in some coal. That would also be cool if I could do that from the inside, right? What you can also do, of course, this chute system, you can just make a little chimney here with 3 or 4 slots and some kind of toss-in slot at the top, and then you toss in like 5, 6, 7 stacks of coal, and then you can run that thing for a long time, for example, controlled by logic whenever the station battery is low. You can also attach... Oh, look at that! What's our ratio? Very low, because the station battery is now part of this logic. I wonder, can I just disconnect that from here? Through the window? No, too bad. Okay. Dim, dim, dim. Is it burning? Yep, you can see by the gas escaping. Which means that now I have also some pollution in here, I think. No? Oh, it's whatever. So now that this is running, I want to do the little fix that I wanted to do quickly before the stack has burned out. I want to just write to all station batteries, so I can basically copy this. Write batch, you know, load, save, save batch. What do we want to do? Okay, what was the syntax again? The device hash. Okay, let's start over. So, SB, device hash is class battery. You don't have to call them this, right? I'm a programmer, I do cryptic shit, so that's the way it is. On 1, that was it. Now we should theoretically see that the battery does no longer look like dead-eyed like this. And here we go, it just turned on. Haha! That was easy. Just one line of code, and we put them horizontally. I cannot get to the switch, I don't have to. Nice all. Nicey nice. Yeah, some more solar panels. For when it is day again. Obviously, it would be advisable to have more solar panels on this opposite side, because then I would save a lot on cables. So let's do that then. Yeah, why not? It's okay. Put it here. Alrighty, so now we have seen a little bit of programming. Maybe we should stick with the programming, because I also wanted to do the deep miner stuff, but the video is already how long? 2.5 fucking hours. Okay, but I think we should do a little bit more programming, because the next things would be not programming related, so why not focus that in one video? Oh, they're both charged? Stop. 14 coal remaining. Cool. Nice. So, what are things that we would like to automate on top of that? There's nothing more that we can do reasonably with this within this cable network, because there's nothing more attached to it, and that is also the idea. Actually, I mean, the actual idea would be that I mean, I have the whole station hanging from this one buffer battery, and that's not wise at all. That is how this all developed. Maybe I should detach that and have the airlock be stand on its own and just connect the whole station to this cable. And guess what? If I have another diode slide over here, and if I hadn't programmed it the way I did, then suddenly I would introduce programming errors by rewiring stuff here. Now I don't. See? You should have some foresight. So we have another thing here. There is a chip somewhere. What do we want to do here? I would like to automatically turn on the cooling when it is so required. We have 43 degrees. Let's see if we can program that in time. A challenge emergeth. I think I would like to make this cooling thing a bit longer. Can I put this here? No. Here maybe. But then I can't wire the cables easily. Or can I? I think that will work, yeah. Do I have enough light cables? No, I do not. When that happens on Vulcan outside, your lungs are burning quite quickly, so be ready to open that thing, or rather to swap out a different tank for your waste tank. Good CO2 ratio for the plants. All 4 plants are done, but I won't do anything with them. Right on cue. I have to open my helmet to eat. Only on easy difficulty, I don't need to. Now I have a whole stack of potatoes in my hand, and I will click here. This will only add 1 potato, but don't click again, because then the recipe will be fudged and then it no longer works. And you should of course try to close the fridge quickly. I think it does suffer from environmental stress, otherwise, I mean, more energy use, or maybe I don't know, maybe there will actually be some minutes lost of your lifetime for the food. I need light cables. So, and I want more pipes. How many pipes do I still have? Now with the nice advanced tool belt, I can just keep the pipes on me, because pipes you need all the time. Wrong. Some iron here somewhere. Yeah, the first thing that we should do really is try to get that arc furnace thing done, because that would be so cool, wouldn't it be? To stand in the base, toss it, and then you hear some clunk. Oh, it's done! You know, that would be awesome. So let's do that next, instead of the cooling thing. I need some pipes. This would make 100 pipes. I don't know if it can crash the game, but it can certainly crowd the base. So that would be this chip over here, which is in the same network as the arc furnace. The arc furnace in turn being connected to everything here. That is in the airlock, so it's buffered by the battery, so the arc furnace is also there. Stack up to 20. Oh, that's fortunate. 22 cables. Now imagine if we just expand the base in that direction, or in that direction. I could put a door here to get through, or I could just have a wide open space or whatever. Currently looks a bit boring. I have no decorations yet, and always using the same stupid boring windows is also not the right choice, but I just want to get things done right now. Okay, how full are our station batteries? That is the overall ratio, you know. This one is this full, that one is that full. How full are we then in sum? Just look at that thing. Okay, the arc furnace. I think I will just do a batch ride to trigger all arc furnaces in the station. I don't know if I would have more than one, but I think it's not wrong to always trigger them on. So how do we do that? Let's start a new software project. The old code is still in there, so we'll just import from the chip that's not in there, or maybe from this chip which is empty. In both cases it clears the text, but you can also just clear here. By the way, there's some help here. You can see some functions and stuff. I rarely look things up here. I got the key things down that I need, and other things I usually look up in the unofficial Stationeers wiki. This is probably more convenient. I just haven't gotten around to getting used to it yet. Oh, there's another interesting feature here. You can say copy, which copies the entire source code into your clipboard. Paste does the opposite, and you can then just use a different editor, Notepad++, for example, which is then the go-to answer, the go-to next step, because then you have all nice editing features. This editor is quite small, but imagine, we're looking at a game here. When do we ever have such a thing in a game? Now, if I press space here, there's no more room. The line is basically over. And if I copy this and paste it here, then it will not paste all of it, and when I delete them I will see it has been lost. And what's even worse is the same happens down here. So if I have a long code, then I insert something at the top, then something will happen that I guess many stationeers have run into already. Suddenly their code no longer works in a certain fashion. It does what it's supposed to one time and it doesn't continue, because many people will have their jump to start statement at the bottom of their code, and that would then have wandered beyond the boundaries here, and then it's gone. It's lost. There's no way to retrieve that, other than, of course, to press cancel. So it's good to have some backups of your save game, which Stationeers creates automatically whenever you save. So what is it that we want to do? First of all, we know that we have a main loop that repeats things. We had that in the other thing too. J start just jumps to a label that I gave. This is just a line number. I'm jumping to the line 5 here, but the number 5 is represented by a word. Now if I press here, the word represents a different number, but I'm still doing J number here. I don't have to know this. Okay, and then we have the yield statement. What is that good for? Well, realize that we are within a game that someone developed with all these things going on, 3D graphics and all the simulation. I mean, isn't this the most complex game you have ever seen in your life? And so some things have to be limited. For example, this code doesn't run at light speed, and if you intend to run it very fast, like not having a yield statement in here, then the game simulation itself will force a yield at whatever point it finds convenient. I think it's after 120 lines of execution that has happened, I'm not sure. Anyway, this will mean that a yield will take place at some position in time that I have no control over. So that's what most people do at the start of their loop. They just do yield one time and then they do their stuff. What does yield do? I think it pauses for one game tick. One game tick is half a second. So that's reasonable. So we want that thing to turn on the arc furnace again and again and again. Is it as simple as just setting that thing on, like SB N, no, not named, I want to turn all of them on, SB class arc on 1? Is it really that simple? Is that the code that we need? Let's see. I will define, I can also define this just to be a number. It's arbitrary, it's really my choice. Class arc hash, the hash function converts the text that I put here into a number. And what do I put here? That's the question. Struct structure arc furnace is what I guess. I have never done this. Dip. No! No, that's not what I mean. I need the arc furnace itself. Structure arc furnace. See, instead of remembering all those numbers or looking them up, you can most of the time just use some name logic. So I define the name here, and then I say write to all the things on this network that have this name, that are of this type, that they shall be on. I don't know if that actually does the trick. Actually, that's wrong. The arc furnace is already on. There is a switch, you know? But there's also this push button. What logic values does this thing have? Power? We cannot even write that. Lock, of course. Activate. That's the thing. I will just write activate. I don't know if that gets the trick done. But if it doesn't, then we will find a way to make it work, I tell you. So, export and run. I don't know what's happening now. Is something in the arc furnace? I'm not sure. I should take some iron here, which is fast to smelt, and then put a single item in there. Fuck me. Okay, I'm not gonna do that now. I need to observe the behavior of the device itself. So, is my copper out? So let's put this here. And it doesn't work. The activate command doesn't work right now. Why doesn't it work? There are several possible reasons. And I'm not sure. But to debug this, I will now go and tell the device, tell the code to not just activate that, but also to turn it on, because this allows me to see that the device has indeed been addressed. On 0 is off, and on 1 is on. So you see logic values are simple, it's just 0 and 1. 174 bytes, so that was not the mistake. Now let's go out and see if that thing... I'm pretty sure I know what's going on. So let's see... Oh! Okay. The solution that I thought it is not the solution. Part of the solution is I need to connect the logic. And I don't have enough of these shit cables. The logic isn't connected, so yeah, not a surprise. Aha, yellow, so that's the right location. Oh, the arc furnace is blocking that. Okay, done goofed. Okay, you see that this thing is being turned on again and again, so I guess the solution that we implemented is actually already the solution. Yep. Let's be bold and assume that this is so and try it right away from the bottom to bask in the convenience of this new situation. So... Hello. I've never done this. This is awesome. Let's put some more iron ore and then see if that will actually stack within the chutes and then all be smelted, because that would be completely kick-ass. Where was I? Yeah, the automation of that. You see, once you get started with automation, things pick up pace rather quickly. Is it powered? Well, if it can flash an arrow, then... aha. And what do we see up there?
Hydration critical.
We still see degassing going on. So, yeah, we are... we now have automated arc furnace situation. That's really cool. I never had that. Man, celebration.
Temperature high.
Oh.
Waste tank caution.
We need to cool stuff down. Should I do this automated? I feel like I shouldn't risk the plants, so let's do one more manual run here, even though it's a bit... aha. So that is on. Now I want to pipe that over there, and I want some of the pipe radiators. We have enough steel for that, but do we have enough gold? I think so. Radiators. Gold and steel.
Filter low.
Yeah, we should also produce some carbon dioxide filters. Oh, right. Temperatures dipping. Of course, when the sun is up, this radiation, this will be much less effective because the sun is casting its light on that thing. And as far as I've understood, oh my god, as far as I've understood, you can even indeed just put some boxes around that or on top of that to... oh, thank you, Earth, for helping me cool my room with that solstice. You can indeed just cast a shadow, and that will then help with the cooling. I think so. Okay, I hoped that would already help. Some steel, please. Do we have some steel? And some gold, please. Do we have some gold? We do. This way? No. And I want more gold. I have gathered so much gold. And now I just don't have to think about it anymore. That is so cool. Ah, goddammit. One, two, three, 4, 5, 6, 7. Let's make 7 then. Do I have enough pipes? Yes, I do. Then I can connect that to this thing. What I will also need is something that... a pipe analyzer, because I want to automate that regarding the pipe pressure. And sadly they botched something regarding the pipe analyzer. They used a name with a typo. I hope they can fix that eventually. In my opinion, as really 30 years of programming, actually it's 40 years by now, I think. Yeah, almost 30 years professionally. It's easy to do that, to have some alternative, basically the primary name and then some kind of fallback name for backwards compatibility that no one will ever get to see in the Stationpedia or otherwise, but that will still work. So they could fix that typo without anyone noticing and without any problems. I'm building these indeed through the window. Oh, goddammit, I'm building them stupidly. Shit. Oh, now I can't unbuild them? Okay. And the pipe analyzer, where will I put that one? I'm not sure yet. Actually, we need more water, it appears. It's a bit dirty to just put it like this, but we'll get the job done. I'm really feeling the larger inventory here. This thing has a display, but the display doesn't do anything. It's just... Oh! Oh, wait a second. Was I not cooling down the room? Look at that, stress 60%. What?! Minus 20 degrees. Yeah, perfect. Exactly perfect, because now we can live with the temperature that we have, and also the temperature is not so low that I cannot demonstrate what I'm about to do once the code is running. This thing is flashing because there's not enough water in the pipes. We have to deal with that at some point, because we do need to drink, and that needs to be repaired. So, let's go outside then. Looking good, battery-wise. Yep. Tell me, I mean, this might be very long for you to watch all this. If anyone is even watching this, I have no clue. I mean, I do see someone clicking on the videos, there's some views, but does someone actually sit through all that shit? But don't you agree that this is super awesome how you can extend it and all the logic and how it all works together? The reality simulation, the virtual reality aspect. I mean, I'm living here in a virtual reality that doesn't really exist, but it has atmospheric simulation, electricity, pressure, temperature, and then also some foodstuffs. There will be more survival aspects soon, I think. But I hope I will first do a debugging run, because the game needs some SOAR debugging. For example, the tutorials are broken, so they need to be locked away. That's something many... Oh my god. 1, 2, 3, 4, 5, 6. I guess I ran out of resources, that's why I only have 6. But, you know, no reason to worry now. Are you still busy? Must be on the very last... Oh no, it's because I keep turning that on. What's going on in there can also be read out by logic, and I can put up an LCD display down here that will show me how far the furnace is. So that would be quite cool, right? Apart from the fact that it's so very cluttered and crowded down here. Okay, so let's turn on this thing, which will pump into the room. And it says outwards very limited. Why? Because there's nothing in the pipe. So what can it pump? Nothing. Even if it is only very low pressure in there, it will give me that warning. It's not a problem. But what happens when I now also do this? See, we're cooling down the room, because the room air is piped through this very strong, very powerful pipe radiator device, and so the room is being cooled. So all I need to do is I have to turn on that thing every once in a while, and if I want to be fancy, and I want to be, I will also turn that thing automatically off once the pipe has been evacuated. By the way, let's turn that on. Realize that we need some power for it. And now we can see what's going on the pipe. Here we have Kelvin information. On the tablet we conveniently have Celsius. Habits. Okay then, let's automate that. We need a gas sensor so that we know what the temperature inside here is. Let's make one. Kit sensor. Copper. Do I have copper here in my pile of smelted things? I do not. How much copper do I need? 1 gram of copper, that is hilarious. Now, let's really enjoy this luxury. I will do that in all my bases in the future. This is so cool. Gas sensor. Where I place this is actually relevant because, you know, let's say I cool down the room here. This means I suck out air here, I pump it back in here. If these two would be more separate, then there would be, for example, this spot where I suck out the air, which might lead to the gas sensor actually not having any air to measure or something like that. It has happened to me. And then the thing would turn on, off, on, off, on, off. Or actually, if I read the pressure, then it might not just be a number, it might actually be not a number, explicitly. And then if I just go and say not a number minus 273.15 so that I have Celsius, then I will have some Celsius degrees, but they are not true, because I just tried to do math with not a number, so all that has to be considered. Sounds very complicated, but isn't. It is, I mean, look at all that stuff that we did here. That is very complicated. But wasn't it fun every step of the way? Yes, of course. And so is this, for a programmer at least. And if you are none, then you're missing out. There are some people who believe that AIs will do the programming for us in the future. I don't quite believe so, or at least that's not relevant for the foreseeable future. So programming is a skill that everybody should have to some degree. Doesn't have to be very sophisticated, just the concept, and god damn it, I can't reach that. So, the gas sensor, if I put it here, then that would not be good. Or, let's say, in this situation where the air is coming in immediately, that would work, but then it would immediately feel cold. So, what's coming in here might be air with a temperature of like 20 degrees, but once it has spread out in the entire room, that will be quite some warmer. So, I need a realistic measurement. That can't be right here where that is happening, it must be further in the room. So, crap, the arc furnace is in the way. That would have been so nice to reuse that. So, as opposed to the airlock boards, which are really fickle, if I disconnect this from the network, I think the airlock board is irrevocably broken. But I'm not sure. If I just reconnect the wire, it might work again, because the door has a unique objective number, a reference number. If I then replace the door with a new door, for example by unbuilding it and building it up again from the same kit, then it would have a different number and the airlock would then definitely be irrevocably broken. But that problem doesn't arise with our logic programming. And that's quite nice. So I also have done a custom airlock at some point. There was a large room which had these vents, except much bigger. They're super powerful. They're made for actually filling and emptying of whole hangars of air. And yeah, programmed that, and it was just as fast as this airlock, even though it was a 2x3 room. So yeah, programming that stuff is really great. So, gas sensor, we need to put that up. Where do we put it? There's already a gas sensor, but we cannot rely on that because we want our cooling to run even when we're going out mining, and then this door is closed, so we have no clue what the indoor atmosphere is. This also means when we now want to measure what this sensor delivers, then we would definitely want to go the named approach. We don't want to use like the average of all gas sensors or the sum or whatever. Now I'll give this thing a name. Now that is in my clipboard. because you can do that in the game. Copy to the clipboard or paste. So this is the code that activates the arc furnace, and we can just reuse the same chip to do some more stuff. I mean, it was 2 lines of code. Really? Let's continue here. Define class sense hash and define ins as in instance sense hash. Programmers know what I'm talking about, classes and instances. For others it will be weird words, but for us it's completely normal, and I will just stick with those. Class sensor will be structure gas sensor, I assume, and I will probably be right. So let's load batch named into the register, whichever register that is, alias just the temperature. Oh, no, room temp is better, because that sounds like the temporary variable. R15 would be nice. So load into the register room temperature from the type class sense, but only the ones with the name ins sense, the value temperature, and if this is multiple, what are you supposed to do with those values? I could say average, I could say sum. I tend to use sum in these situations because I would rather be in a fail-fast situation, as in the code will most likely fail if something is wrong, and if I have multiple gas sensors with that name in this wire network, then yeah, something is wrong. Then I'd rather want this thing to fail to tell me, dude, something is wrong. This is then more ways for me to find out that something is different than it should be. That's why I use sum. Now let's say subtraction into the, you always first say the target. Here when you save, you say into that. When you load, you say into that register. When you subtract, you say into that register. Now we want to know what do we want to subtract and what do we want to subtract from that. Well, we want to subtract from that register the value this Kelvin. So this is the target, and what goes in the target is the difference between that, and then we will have Celsius. Okay, now I want to say if the temperature is above 23 degrees, turn on that cooling apparatus, and else turn it off. Later we will be a bit more elegant about that, but first we will just go this way, which will probably do click, 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 click all the time. The tolerance comes later. So branch if greater than. Now, what is the source of the greater than comparison? The room temperature. And with what do I want to compare that? Let's say 23. If it's greater than 23 degrees, then jump to the following location, turn on cooling, or just cooling on. Cooling on, and here we will then say write to the device type vent. Which one do we want? Vent out, because we have 2 vents. We will actually deal with 2 vents in the same code, but it will always be just the class vent. It's just the type, right? What do I want to write there? I want to say on 1. And that's it, right? Except what happens if the temperature is not greater than 23 degrees, then it will not jump from here to there, but it will just, instead of jumping, it will walk there, basically. So let's make sure that this doesn't happen. Cooling done. And then we just jump there. But that's not it. That's not quite it yet. Because this thing doesn't have to be turned on, it also has to be turned off. And so we say whenever the temperature is not greater than that, just continue execution here, and then say turn it off, jump, cooling, done. So we had like multiple uses here of this jumping. So with this approach, I mean, you could of course just say jump start, but this would mean that we cannot do more stuff down here. That's why I like to use these kind of logic blocks, which then have an explicit ending marker to which I then jump and then can do more stuff, even if the next thing that comes is jump start. This leaves it open for the future, you know. Okay, that sounds good. But we would want to, if we need the class event.
Air tank critical.
Yeah. Define this hash structure active vent, I think. CLS vent, what is the name that I thought of? None yet. I didn't think of a name yet. Oh, that was wrong. Ins vent out hash let's use a more programmer-ish name, cooling vent out, which is then the name I have to give to the vent. I can use copy-paste or I can do it manually, but obviously if I do it with copy-paste, then I'm excluding another potential point of failure. We can also go here and already name this one for later. Now I will turn this on, which sucks the pipe dry. And I will open the helmet. And I will switch out, I will get some more air. And then we look at the temperature that the room has. Where can we see that? We can see that right here. We have 28 degrees Celsius. So that should basically turn on, right? Let's look at the code again. Now arc furnace, we don't care about that. We want the type structure gas sensor. We want the instance room atmosense. Did I actually give it that name? I don't remember. So let's point at the thing up here and then we see room atmosense instead of gas sensor. So that was right. Then we have the structure active vent and the instance vent out. While we're here, we can just already put the other one here. And the editor does not yet complain, sadly, that the name is already taken. We don't need that yet. So then we say the register of room temperature shall be 15. This is the arc furnace stuff. Let's move a little down here. So we load the room temperature from the class sensor in sensor temperature sum. Then we subtract into room temperature from room temperature that Kelvin stuff. Then we say if room temperature is greater than 23, we branch down here to cooling on, and then we say write into class vent ins vent out on 1. Else we write ins on 0 and cooling done. This should work. Let's see. Export, and the cooling just went switched on. What has to happen now is the temperature in the room has to decrease to 23 degrees. And it will probably dive deeper because we're closer to the cool stuff. The sensor is over there. And then it turns off. And then it turns on very quickly again because of some wobbly, wavy effects of the room air wafting around, so while we're still close to the threshold. And then that will happen a few more times, and then it will shut up for a while. Yeah, let's see what happens. Ah, see, it's colder now, but it has turned off. Now it's heating up again. If I would have put the gas sensor at the very opposite of the base, we would probably cool down the base to something like 20 degrees or so. Because there's just so much cold air that comes in before the thing realizes, oh, it's warm enough. Cold enough. The placement over there might be ideal. We can probably also observe it reaching 23 again. Thankfully the sun is up, helping us to reach 23 degrees. Dum, da, dum, dum, da, dum. And when it reaches 23 here, this thing will not turn on because of rounding. But then... Come on. Here we go. We have automated station cooling. The problem has been solved. Inelegantly, but it has been solved. In the same way, we could now put up a wall heater and say if the temperature is below this and this, turn the wall heater on. But that's not a problem that we'll be having, so I will not go into that now. That thing though, that sucks. Let's make sure that this is only on when it needs to be on. What names did we use here? Oopsie. Cooling vent in, cooling analyzer. Confirm. Okay, and we have to define another device up here. Define CLS anal, excuse me, hash structure pipe analyzer is what you think, but they done goofed. That's how you actually type it. Define ins anal hash. Okay. Now we want to know the pressure in the pipe. The pressure is not a Kelvin thing, so you don't have to subtract stuff there. What we also want is that this thing is definitely on, right? I mean, if that thing is off, it will leave give us not a number. We don't want that. So that is the one vent stuff dealt with. Now let's deal with the other one. Let's have another alias here. 14. Pipe pressure, pipe press, and then I will read the pipe pressure, load batch named into that CLS. What I want is the pressure, and if there's multiple, just add them, sum. So now I want, if the pressure is greater than 0, that you say evacuate pipe, else don't. J. Clumsy word. And yeah, I wanted to do something. I wanted to first make sure that this thing is turned on. So we say write. So we don't have actually a register here because we directly start with the target once more. This is the target of this operation, that is the target of that operation. And what we want to do is we want to write lock 1, because I don't want to accidentally turn it off. It wouldn't hurt because I'm turning it on explicitly here, but I think there's never a reason for that thing not to be on ever. And what did I do here? Now this is one of the quirks of the editor that I described earlier. I just destroyed the line thoroughly. So what has to happen? First we say lock that thing, turn that thing on, then load temperature sum. So if the temperature? No, pressure, god damn it. If the pressure is greater than 0, then go here. And what we want to do is we want to control the other vent. We want to turn it on, and we want to turn it off, but not this one, this one. So I did something wrong. What did I do wrong? Right, greater than 0, what is greater than 0? The pipe pressure. Hypothetically, that's already it. Okay, there's no apparent programming error. Now this thing has been turned off automatically. I still have control over it. Oh, something else. The direction. I can change the direction. That's maybe some nice flexibility to have, so that I can interfere with the device, but it's best to just turn off the chip so that I'm in control, as long as the things are not locked, because they would stay locked, as I showed earlier. I would also like to set the direction. That is actually easy to... Look here, I cannot turn it off. That's actually easy to remember what the direction is. It is the mode, and that's like on and off and like lock, a value that many devices have. The mode is easy to remember what the modes mean, because let's just say you're standing in a room and you're putting up an active vent on the wall and you turn it on. Do you want your life to be endangered? No. So you want to be safe, right? So if that thing would suck out the air from the room, that would be danger. So that shouldn't be the default mode. So the default mode, which is obviously 0, is the mode that pumps into the room. And mode 1 is the internal pump that pumps into the pipe network. That is how you can remember that. Room temperature. So let's go here and say I want the vent in to always have the mode. What does in mean? In means I want to pump back into the room, so that would be mode 0, and the other one shall have mode 1. We will see very quickly if that was correct. Aha. Ah, look at that. Yeah, I think we can say it works perfectly. Nice. And it's not that much code, right? I mean, it looks like a lot of text, but once you understand what the individual things mean, I mean, it's like, look at this station. If you don't know what all of this is, then it looks like, what the fuck is this crowded, chaotic bullshit? But now that you know what everything is, you're basically looking at meanings instead of at chaos, and that's exactly how a programmer looks at code. That means something, that means something, so it's not that much code, really. Okay, was there something else that I wanted to automate? The arc furnace is automated, the cooling is automated, the station batteries show their content. I think, and we have enough solar panels. I think this is a well-rounded video by now, apart from all the extra talk that is unnecessary, like this, for example. And so let's conclude this for next time, when I plan to do a deep mining and centrifuge and all that stuff. Goodbye.